In our previous part, we have formed, with the help of this given equation, we have considered our individual diagram for our signal flow graph over here, and at the last stage we have combined those four individual diagram to have the final diagram over here, and this is gonna be the final signal flow diagram over here, or final signal flow graph over here. Now in our next stage we should form, or we should get to the point on how to consider or how to deliver the transfer function with the help of the signal flow graph over here. Let us just do that. I want to repeat this portion once again. First, we have got this four individual equations over here, and just by looking at this given equation, we have formed our individual diagram over here. Now, at this stage, or just by looking at this given four individual equations, we have got four individual diagrams over here, and at the last stage we have combined these four individual diagrams to have the final signal flow graph over here. Now in our next stage, or in our next point, we should consider this signal flow graph to have the final transfer function over here. Let us just do that for this consideration point, or for this considered part. Now once again we should draw the signal flow graph over here. Now this is going to be our input, that is been considered as our R, and this one is our x1, this one is going to be our 1, and after that one, this one will be our x2, and this one will be our x3, and the output node of C will be present over there. Just do like to connect this individual signal flow graph over here to have the final answer. In between our x1 and x2, we have got the signal as -6. This is going to be -6. In between our x2 and x3, we have got the signal as -9. This one will be our -9. In between our x3 and C, we have got the gain as 3. So this is going to be our 3. Okay? And in our another part, we have got our self loop consideration at x1, x2, x1, x2, x3 node over there. At the x1, the self loop gain will be our 7. For our x2, we have got the self loop gain that is been considered as our 4. Now this one will be our 7, this one is our 4, and for our x3 we have got the self loop as the gain is 6. Okay? Now we do require to consider from x2 to C point over here. From x2 to C, we have got the gain as 1. This is going to be as 1. In between our x1 and x3, we have got the gain as 3. In between our x1 and x3, we have got the gain as 3. In between our x1 and C, we have got the gain as 2. Okay. Now let us just consider our loop over here. In between our x3 and x2, we have got the feedback loop as 8. This one will be our 8. In between our x2 and x1, we have got the feedback loop as 2. Now in between our x3 and x1, we have got our another loop, and the gain for that considered part will be, or for that path will be our 5. Okay. Now let us just recheck over here. First we have got the input node as R, and we have just clearly zoom it out over here to see this is going to be our final signal flow graph over here, and in our next stage we just do require to form the signal flow graph just by looking at this given diagram over here, or in the another sense, just by considering our Masongen's formulation or Masongen formula, we do require to form the transfer function just by looking at this signal flow graph over here. In between our R, in between our x1 and C, we have got the signal as 2. In between our x1 and x3, in between our x1 and x2, we have got the gain as 3. In between our x2 and C, in between our x2 and C, we have got the gain as 1. And quite naturally, in between our x3 and x2, x3 and x2, the gain is gonna be 8. In between our x2 and x1, we have got the signal as 2. In between our x3 and x1, in between x3 and x1, we have got the feedback signal as 5. We have got the self loop that has been considered at the node of x1, and the gain for that one will be 7. For our x2, that one will be our 4. For our x3, that one will be our 6. Okay, and this is our overall picture over here, and let us just check whether any part of our loop or any part of our forward path that has been missing over here. And I don't see any missing link or missing path over here. I have totally considered the total diagram and consider or magnify this in the left hand side for our diagram to see this is going to be our final signal flow graph over here. Okay, in our next part we are just going to form the Masongen formula just by looking at the signal flow graph over here. I hope you have totally understood up to this one. If you still have any doubts, please let us know in the comment section for better understanding. Do like, do share our videos and keep following our channel. I want to repeatedly say the same thing over here, that Engineering Brother is gonna be the special channel over here. And how do I say that? Because no other YouTube channel would like to give you this type of detailed analogies over here, and they are just trying to solve some simplest problem over here. But Engineering Brothers' main objective is to not only clarify your doubt, but it just show you the total picture on how to solve this type of challenging problems over there. That is the specialty for our classes. So what are you waiting for? Please do follow our classes. Do subscribe our channel, hit the bell icon for more updates, and stay tuned to the classes. Just wait for my next part. In our previous step, we have clearly draw the signal flow graph over here. In our next stage, we are just required to form the transfer function, and that will be the end for our problem 5 for our signal flow graph over here. I hope you have totally understood up to this one. If you still have any doubts, please let us know in the comment section for better understanding. Do like, do share our videos, and keep following our channel. In our previous part, we have formed the signal flow graph over here. Now just required to consider our much needed Masongen formula over here. So what is the Masongen formula? The Masongen formula will be, the transfer function will be our, say, P1 delta 1 plus P2 delta 2 divided by delta. If we have got two forward paths over here, and that is been moving just like that one over there for the many number of forward paths over there. In this present case, we have got what seems to be the number for our forward path over here. Let us just show you over there. According to the Masongen formula, this is going to be our transfer function expression for our given signal flow graph over here. Now just looking at this given equation, we have formed the much needed signal flow graph over here. In our next step, we should form the much needed transfer function expression with the help of our Masongen formulation over here. Now let us just consider what are the forward path are here, the first forward path will be say P1, and that one, the gain for that forward path will be -6, -9 and 3. Okay, -6 multiplied by -9 multiplied by 3, which one will be our 54 multiplied by 3. And what is the path marking from our input to output over there? The marking path for that forward path will be from R to X1 to X2 to X3 and then C. Okay, this will be our fast forward path over here. And let us just consider our another set of forward paths over here. Say in our next forward path, the next forward path will be this one. Okay, now the next forward path will be say from R to X1, from R to X1, then to X3, this one, then to our C. Okay, now what seems to be the gain for that one over here, which is 1 multiplied by 3, 1 multiplied by 3. Okay, and then finally the 3, this one, the gain for that path will be 9. Okay, for that next forward path we have got our this part over here, which is, once again I am just going to write down our path for our forward path over here. It is quite naturally has started from R to X1, then to X2, then to our C. And the gain for that particular forward path will be 1 multiplied by -6. Okay, then to our 1. Now gain for that path will be our -6. Okay, and we can see our another forward path that is been from over here, which is, once again I am just going to say that particular forward path will be our 1 multiplied by 2, 1 multiplied by 2, which is going to be, the gain for that will be our 2. Now what seems to be the path for that forward path? The path for that one should be from R to X1 and then X1 to our C. Now these are our 4 forward paths that we can indicate or we have considered over here, and the modified transfer function for that present consideration will be because of this P1 delta 1 will be there, P1 delta 1, P2 delta 2 plus P3 delta 3 and P4 delta 4 will be there. Now I am just going to modify our given transfer function for this present 5th problem over here. In this case, the transfer function will be our this one, which is P1 delta 1 plus P2 delta 2 plus P3 delta 3 and once again plus P4 delta 4, P4 delta 4 divided by our delta. Okay, we have considered the forward paths over here, P1, P2, P3, P4 over there. Let us just note down the expression for our forward path over here. For our forward path P1, the gain will be our 162. For our P2, we have got the next forward path as our 9. For that third forward path, we have got the next forward path as our -6. And for our next forward path that has been considered as our P4, that one will be our 2. Okay, so these are our forward path that we have enlisted over here, and we have indicated the direction that is been started from our input node as our R, and that without changing any direction of our arrow, it has directly ended at our C node over there, which is going to be our output node over there.
quite naturally you can do see that or do feel that the exact definition of the forward path is properly indicated over here, which is quite naturally this is going to be our given consideration over here, and it has started from R node and it has ended at our C node over there without changing any direction of our arrow over here. Quite naturally, we are going to show you once again the forward paths over here. Our first forward path will be our from R to X1 to X3. To X3 means this one. No, this one will be a first forward path, which is from R to X1 to X2 to X3 to C. And in between those paths, we have got all those following gains over there, and we have just included that gains in order to have the final answer for our forward path over here, which is 1 multiplied by -6 multiplied by -9 multiplied by 3, which is going to be given us the first gain for our forward path over here, which is 54 multiplied by 3, which is going to be the answer will be 162. In our next section, we have got our second forward path, which has started from our R, and then it is going to the X1 and then X1 to X3, which we have got the path gain as our 3, and from X3 to C over here. And quite naturally, the forward path for that consideration will be our 9. In our next part or in our next section, we have got the P3, which is our another set of forward path over here, which has started from R to X1, then from X1 to X2, and then from X2 to C over here. Quite naturally, the gain for that considered part will be 1 multiplied by -6 multiplied by 1 over here, which is going to give us the resultant gain over here, which is our -6 over here. In our next part, we have got our another gain for that considered part over here, which is from R to X1 and then X1 to C over here, and quite naturally the forward path for that consideration will be our 2, and we have enlisted our 4 considered forward path over here. Okay, in our next section, we do require to form or to get the value for our delta 1, delta 2, delta 3, delta 4 over there. But before I go into that, I want to find out first the much needed expression for delta over here, which is going to be very interesting for our upcoming part of our video over here. Just do follow our classes. That is the best possible way to understand all the considered part over here. I hope you have totally understood up to this one. If you still have any doubts, please let us know in the comment section. For better understanding, do like, do share our videos and keep following our channel. Just wait for my next part.
If you like my video, so what are you waiting for? Please do subscribe my channel, hit the bell icon for more updates, and stay tuned to the channel. Thank you and goodbye.